Okay. Look, Monica, Monica, how are you, Monica? Your microphone was not working at the beginning, right?
Yes, sir.
Yes. So uh, we gave the homework question 3, then 6 to 10, right?
Yes, sir.
So did you try them?
Yes, sir.
Okay. Okay. So Mahi, please read question number 6.
Okay, sir. As a sound wave travels from one medium to another, its wavelength increases. What happens to the frequency and to the speed of the sound?
Yes, this idea we got. Where we got this? In topic 13, we also got the same idea, right?
Yes, sir.
So what should be the answer? We got the idea frequency is always same, right?
Yes, sir.
Yeah, frequency is always same. So we got here C or D, right? Either C or D will be our answer, right? So which one should be our appropriate answer? C or D? We have to take in the wavelength. Wavelength, it is increasing or decreasing? It's given wavelength increases, right?
Yes, sir.
Isn't it? So what will happen to speed? Who can say the answer? Who can say the answer? Who can say the answer?
The speed increases.
Speed increases. Very good. So this one we can easily understand from one formula. Which formula is that? Which formula is that? Which formula is that? Can you remember? Did you learn one formula? V equals F lambda?
Yes,
Hmm?
sir.
Yeah. So that formula is helping us to understand it. Like we have the formula. I'm writing the formula. We have V equals. You also write, please. You also write. Have you taken the printout? If you did not take the printout, at least you write. It is worksheet. Today we are doing worksheet on topic 16 sound MCQ 6. There you write this formula. V equals F lambda. Huh?
Yes,
F
sir.
lambda, right? Yeah, I'm writing. That means speed equals frequency into wavelength, right?
Sir, my computer is having some problems.
What
It's not
problem?
opening the file.
Frequency times wavelength, right? What problem, Mahi?
Sir, the file isn't opening.
Okay, from the Google Classroom.
No, sir. I downloaded it.
Okay, okay. So one thing
Okay, sir.
you
Now
can
it's working. It's working.
is it's okay now, right?
Yes, sir.
So frequency into wavelength. Now, if your frequency is constant, then if your wavelength increases, speed will also increase, right?
Yes, sir.
So this formula is helping us to understand it, right? Remember it always. Next time the same question is coming, you should answer correctly, right?
Yes,
Farabi,
sir.
Balabi,
Yes, sir.
read next question, question 7.
A sound wave in a solid is represented by a series of lines. The diagram shows compression C and rarefaction R at one instant in time. Which statement is correct? All particles on one line move in the same direction at the same time. The direction of travel of the sound wave is parallel to the lines. The distance between a compression and its adjacent refraction is a wavelength. The pattern of lines represents a transverse wave.
Okay, so this one is a bit, idea. Uh, this one is containing the idea of deeper knowledge, and we can find the answer by like this one. They are saying a sound wave, right? They are saying a sound wave in a solid is represented by series of lines. So if it is sound wave, then should it be transverse wave? Will it be transverse wave, or it should be longitudinal wave? Sound, anyone please? Sound is transverse wave or longitudinal wave? So
Longitudinal.
Longitudinal wave.
yes, longitudinal wave. So we can ignore option D, right? From here. Now, next one, you see C, what they said, the distance between a compression and its adjacent rarefaction is a wavelength. We know that wavelength is from crest to crest or trough to trough, right? Isn't it? So compression, showing compression here, compression we said it is representing crest, and rarefaction is representing trough, isn't it?
Yes, sir.
Yes.
So from one crest to one trough, it's not the wavelength, it's the half of wavelength, right? Isn't it? From crest to crest will be the wavelength, isn't it? Hello?
Yes, sir.
So in question 7, you take the notes that from one compression to another compression is wavelength. Here, so that's why we cannot take C. Now, option B, what they said, the direction of travel of the sound wave is parallel to the lines. So, the direction of travel of sound wave is parallel to the lines. Sound wave is traveling right side, isn't it? Hello, are you understanding what I'm saying?
Yes, sir.
Hello. If you have compression, what we know in longitudinal wave, we know that compression and rarefaction is happening going forward and backward, right? Isn't it?
Yes, sir.
So the line are given upward and downwards, right? Vertically, the lines are vertically given, isn't it?
Yes,
And
sir.
our wave is going right side. Energy transfer is shown right side. And that's why this statement is not correct, because they are saying the lines, if the lines are this, their parallel direction is our wave going. The wave is not going in this direction. I'm showing you. If we take this statement, we are taking like our wave is going in this direction or this direction, right? Parallel means this or this direction. But Wave is not going parallel direction. Wave is going to the perpendicular direction of the lines. This is confusing. This statement a little bit confusing with the definition. That's why students are, confused. Becomes confused. Look, this is a tricky part. We have try to understand, please. Then you'll get it. This part is making this question difficult. Look, here. Okay, it is it is the direction of wave travel. I'm labeling, then you'll understand. Wave travels in this direction. And the particles vibration is forward backward, right? Isn't it? Hello,
Yes, sir.
everyone, please respond. In longitudinal wave, particles vibration is forward, backward, or parallel with the wave direction, isn't it?
Yes, sir.
Yes, sir.
Is if we take this one in consideration, so uh, the lines, they are highlighting lines. They are not highlighting the particles vibration. That is making you or any student confused. Like our particles vibration is like this. I'm showing you here. Okay, I'm labeling it. This one is particles vibration. Particles. This is longitudinal wave, right? But what they are saying, look, they are saying the direction of travel of the sound wave is parallel to the lines. So parallel to the lines to be the wave direction should be either upwards or downwards, right? Isn't it? Hello?
Yes, sir.
That's why this statement is wrong. Is it clear?
Yes, sir.
All of you clear?
Yes, sir.
Okay. So this one we are getting B, C, D, all of them we are taking as wrong statement. Now you see A. All particles on one line move in the same direction at the same time. This is correct. Like uh, if we take this line, you know about wavefronts, right?
Yes, sir.
Can you remember wavefronts? So in wavefronts, all the particles on one line move in the same direction at the same time. That means in crest or trough, all the particles are moving in the same time in same direction. Can you remember that one?
Yes,
Yeah,
sir.
in wavefront. Yeah, so we can take A as our correct option. Is it clear now, everyone?
Sir.
Hello?
Yes, sir.
Okay, thank you. I'm writing some information here, then Monica, you take the snap. This one is longitudinal wave. Sound is longitudinal, not transverse. That's why we cannot take. Then second statement, why is not correct? From compression to compression. To compression. Okay. If it is from compression to compression, then we can take this option as correct. Now it's given compression to rarefaction. Then B is already explained. A is explained with the wavefronts. So Monica, can you please take the snap now? Send to our group. Amjit. Amjit left. Amjit is from, O-level candidate batch. He mistakenly came now. He is going to take this next May June O-level exam. So Monica, have you taken the snap?
Yes, sir.
Have you sent?
Yes, sir.
Thank you. Now this one is very easy. Yeah. Mahi, you read it, huh? Mahi?
Okay, sir.
This one is very easy.
A phone rings and lights up. Which type of wave are associated with the phone's operation? Light is sir D.
Light is which type of wave? Is it transverse or longitudinal?
Long.
Yeah, in your record copy, if you check, you will find it. I gave you some examples of longitudinal wave, some examples of transverse wave, right?
Yes, sir.
So do you have that note in your copy?
Yes, sir. Oh, sir,
So,
light is transverse wave.
yes, and sound is,
Sound is longitudinal.
yeah, just now we discussed. So what should be your answer?
Sir C.
Yes, C for correct, right?
Yes, sir.
So C is the answer. Okay, very good. Now you should memorize them, right? Which are transverse wave and which are longitudinal wave. You should remember. No confusion. Eh?
Okay, sir.
Now 9. Continue 9. This one also we did before. 9.
The diagram shows the surface of water as a wave passes across a ripple tank, which lengths represent the amplitude and the wavelength of the wave.
Which one?
So should we say the half of our amplitude or like the full amplitude?
They are asking you amplitude. So which one is amplitude? Q is amplitude or R is amplitude?
R.
R is double the amplitude
So P.
because the line here in the middle, it is rest position, right? So from rest position to the crest or rest position to the trough, we have the amplitude. Is it clear?
Yes, sir.
Never forget, huh?
Okay,
And
sir.
and which one is wavelength?
Sir, P.
Yes, P is the wavelength. So what should be your answer?
A.
A. What is S?
S is half of wavelength.
S is half of the wavelength. So R is double the amplitude, right?
Yes, sir.
Always remember that. Now, Farabi,
Yes, sir.
yeah, question 10. Continue.
Sound travels at different speeds in solids, liquids, and gases, which leads show the states of matter in increased speed of sound, slowest to fast.
Sir, Dhaka.
Slowest to fastest. It's like
Oh,
opposite. In the way we are getting in this medium, the one you said, you make it reverse, then you'll get your answer.
sir, then A.
Yeah, it's A. Why it is A? Because there is one explanation. We got in notes that sound is mechanical wave, right? The first thing is sound is mechanical wave because sound requires medium to travel. Now, another point is there that sound travels by vibration of the molecules, right?
Yes,
Isn't
sir.
it? So when the vibration will be more, then transfer of energy will be easier to the next molecules, right?
Yes, sir.
Transfer of the molecules will be easier if they are more closer, isn't it?
Yes, sir.
So in gas particles, liquid particles, and we have solid particles, where is molecules are much more closest in solid, right? Where the molecules are closest, tightly packed in solid, right?
Yes, sir.
That's why sound can transfer energy fastest in solid. Then in liquid, the molecules are little bit farther apart, right? Isn't it?
Yes, sir.
That's why in liquid it can it can pass more faster than gas, but less than solid. And in gas, molecules are very far apart, right?
Yes, sir.
So the vibration of molecules, uh, by vibration of molecules, transferring of energy will be less or slowest the gas. So it's clear now, right?
Yes, sir.
We'll never forget it, right? Okay. And we also got the typical, um, speed of the sound wave in solid, liquid, and gas. The value we got in notes, like in gas or air, it is approximately 300, right? 330, 340, like that. It depends on the density of the air. Then liquid is almost 1500. In water, it's almost 1500 meter per second. In solid, like steel or iron, it's almost 6000, uh, 5500 or 6000. Is it clear? So,
Yes, sir.
so we know these values, Monica, right? You have written all these notes in your copy, right, Monica? Hello, Monica.
Yes, sir.
Look, Mahi and Farabi, I actually want you to have the completion of your work, right? For each of the topics we are doing. Look, Monica already took topic 13 exam uh, test. That one she took, and before that she gave me sound notes. Even we did the sound notes completed. We had completed it last Saturday. So on last Saturday, it was 5th of December. That time she sent me this one. Okay, so this way I also want want you to send me so that I can check. Like if I go through her notes, I can check if there is anything missing or not. Then I can say her, or anything mistake. I can say her, right? Look,
Sir, can I give it tomorrow?
yeah, I'm saying you that it actually I cannot give you pressure now because your exam is going on, right, in the school. Otherwise, I would talk to your parents even. That's why I'm taking time that your exam is over and you be free, then you finish your work, which is incomplete. You see, is it clear to you?
Yes, sir.
So this way, I want you also to send me the notes so that I can check. Yes, your understanding or your writing, anything is missing or not. You have everything or not. Otherwise, if you don't have these notes, you cannot get it, right? You look here, she has almost everything. What we gave in notes, uh, the, the most of the important things are available in our notes. So at least you have these notes, you can remember, yes, we learned this, we had discussion on this. You can recall, right? Because the notes I made, that one is more details, right? Isn't it?
Yes, sir.
So all these things from the notes you cannot have in your mind, but at least you should have this. What I said to write. If you have this, then you can at least go through the working basic thing or fundamental things which we must need. Okay, so you have here, look, this idea, speed of sound, yeah, uses of ultrasound, yeah, you see, sound requires a medium to travel. This one experiment, Belger experiment, change this one. See, speed of sound is different in different medium. She wrote air, then water, hmm, then iron. So from here also you understand where sound is fastest, where it is medium, where it is slowest. You can understand from this list, right? Is it
Yes,
clear?
sir. Yes,
And
sir.
in a Cambridge question, this way question is coming about sound speed in different medium, and also they give you this type of question where you have to know the typical value like speed of sound in steel, speed of sound in water. So which one is necessary for you? That one I am giving you. Huh? Not giving you everything. I know about the question pattern. I analyze them in previous years, at least 10 years, 15 years, how the questions are coming. So that way, I prepared the notes, and also that way I prepared the worksheet. Is it clear to you? So if you solve it by understanding, then you can solve any kinds of question is coming from sound. So till question we are done now, right? Yeah, Monica, you joined. Monica, you joined a little
Yes,
bit
sir.
late. So what I discussed with them. Now I'll give you break for 20 minutes. 20 minutes
Okay, sir.
break. By this time you can have snacks or you can offer prayers if you want. Then we'll start our class 7:45. Okay?
Okay, sir.
7:45 to 8:25. Our another 40 minutes class will continue. Okay? Thank you so much.
Okay, sir.
Join again 7:45. Okay. Bye.